In this video, I want to go over the basic derivative problems that came from the first page of your first 9 weeks test. 36 of the 100 points were on this first 9 problems. So the basic rules that we're using were the power rule that says the derivative of x to the nth power is n times x to the n minus 1. In words, you just bring the x out front, then you lower the power by 1. Here is then the product rule, the derivative of f times g. In each part, notice you take one derivative and then leave the other function alone. So it's f times g's derivative plus g times f's derivative. The derivative of a quotient, f over g. You square the denominator, take the original denominator g and write it down, multiply times the derivative of the numerator. That's a minus sign, make that a little bigger, minus the original numerator times the derivative of the original denominator. This is the one where we learned the little rhyme that said low d high minus high d low over the square of what's below. The chain rule comes next, and the chain rule says to take the derivative of a composition of functions, f of g of x. We refer to g as the inside function and f as the outside function. You differentiate the outer function, leaving the inside function totally alone, like it was just an x, then multiply times the derivative of the inside function. So on our first page here, we're going to apply the power rule 3 times, a couple special cases in here. But the most general case is I bring the 3 out front, multiply it by the 5, that gives me 15. I write down the x and lower the power by 1, making it 15x squared. This is the derivative here. Okay, the derivative of anything times x is just the number that's being multiplied by x. So this is the derivative of minus 2x is minus 2. And the derivative of 6 is 0, so that's my total answer. On number 2, you need to first understand that this is the same as writing x to the 4/3 power. That when you take, in root notation, x to the 4th and then the cube root, when you write it in fraction notation, the power goes up top and the root goes below. Now we use the same power rule that we used in number 1 on the 15x, on the 5x cubed. Okay, so my derivative, my y prime, I'm going to take this 4/3 and bring it out front. Okay, I'm going to write it down here. That's 4/3 x. The power gets lower by 1. 4/3 minus 1 or 3/3 leaves you with 1/3. The only thing left to do, and again this is y prime down here, the only thing left to do is to rewrite this in in root notation. So the only term that's a denominator term is that 3. The 4 is a numerator term, and because x is to a positive power, it's going to the numerator, and it's going to be the cube root, because of the 3, of x to the first power. So there's your answer. On problem 3, you were instructed not to use the quotient rule here because we wanted to see that you could divide by every term by x. So this is the same as y equals 8x over x minus 3x squared over x. You can simplify that further. The x's cancel in the first term, leaving 8 minus, and x squared divided by x is x, so that's just 8 minus 3x. A nice easy function to take the derivative of. The derivative of 8 is 0, and the derivative of negative 3 times x is just the negative 3, and that's our answer. You may have heard me in class say that when every term has a power of x, you may take one power of x out of each of them, and effectively, when I rewrote it, that's what happened. Okay, our next one is our first chain rule problem. You have something to the 6th power, okay? Now, if that was just x to the 6th, you would get 6x to the 5th. So what we're going to do is treat that for a second like it's a big old x. We're going to bring the 6 out front. 6. We're going to write this term down, leaving the inside alone as the words of the chain rule. And now that would be lowered to the 5th. So it's 6, 5x plus 8 to the 5th. And now you're required to multiply, because this was not just a plain old x on the inside. You're required to multiply times the derivative of the inside, and the derivative of 5x plus 8 is simply 5. We get on number 5 another chain rule. You differentiate this just like you would the sine of x. The derivative of sine x is cosine x. Well, we're going to treat this like it's a big old x just for a second. So this is cosine of 5x cubed. And then we multiply, because this was not just a plain old x, we multiply times the derivative of 5x cubed, which is 15x squared. And there's your answer. We have another product rule in number 6. I say another, maybe my first. Yes, this is the first. And so what we're going to be doing, this is my f, this is my g. And we're going to take f times g's derivative plus g times f's derivative. Okay, so that's over here. This is just the product rule that I've written underneath my answer line. So f is my first function. That's the x to the 4th plus x. I just write it down. I multiply times the derivative of the second function. The derivative of cosine x is negative sine x, and then plus. Plus is because there's a plus in the middle of the product rule. Okay. This time I write down the second function, the cosine x, and I multiply times the derivative of the one I left alone the first time, f, which is the derivative of x to the 4th plus x is 4x cubed plus 1. Notice that last set of parentheses right there is required, and so is the set of parentheses on the x to the 4th plus x. The parentheses around these other terms, I just put them there because I like them. I guess it's actually required on the sine x because you have a negative in front of it, and if you didn't, it'd be interpreted as subtraction. Okay, number 7 gets us to the quotient rule. Okay, so that was our, if it was the f over g that we were taking the derivative of, the quotient rule said we square the denominator, write the denominator up there, derivative of the numerator, minus the numerator written down, f times the derivative of the denominator. So that's the rule we're going to apply. My denominator is x to the 4th, so I'm going to square that, and that makes it x to the 8th. X to the 4th squared, you multiply the powers together. Now I'm going to write down the x to the 4th. I will multiply times the derivative of the numerator, which derivative of sine x is cosine x, and then minus, because there's a minus in the middle of the quotient rule. This time I'm going to write down the original numerator, which was sine x, and multiply times the derivative of the denominator, and the derivative of x to the 4th would be 4x cubed. Okay, so we had the old rhyme, low d, meaning derivative of high, minus high times the derivative of low, high d low, over the square of what's below. On number 8, we have a chain rule that has a product rule inside of it. Okay, so we treat this at the first stage as I'm just doing the derivative of something to the 5th, which is going to be 5 times that something to the 4th. So that is your first step. 5 times 2x sine x to the 4th. Okay? Now, so we differentiated the outside function, leaving the inside part alone, and now you multiply times the derivative of the inside part. Well, this is 2x times sine x, so that means we have a product rule to do. And I'm going to group the 2 with the sine x as I think about it. So this is the first term written down, 2x times the derivative of sine x, which is cosine x, plus, this time I'm going to write down the sine x and multiply it times the derivative of 2x, which is 2. So I differentiated the outer function to the fifth power function. I did 5, the inside to the fourth, and then the chain rule says take the derivative of the inside, which was a product rule. On our last problem, I wanted to make sure that you knew how to handle this guy without using the quotient rule. You simply want to rewrite this. The original function, y would be 7x to the negative 2. And x squared in the denominator is x to the negative 2 power. Now we're just going to use the power rule. This will be 7 times negative 2, or negative 14. X to the 1 less than negative 2 is negative 3. And I'll rewrite that with non-negative exponents. This is negative 14 over x to the negative 3 means x to the positive 3 in the denominator. And those are your first 36 points on the test. I hope you do much, much better. If you had trouble with those on the practice, on the first 9 weeks test, very quickly, we'll go over the next 4. I said I was going to quit after the derivative, so we're just going to keep going, at least on these next 4. These are just memorization. The derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of tangent x is secant squared x, and the derivative of cotangent x is negative cosecant squared x. Notice that the co-functions these are essentially the same rules with the co-functions used, and the derivative of the co-functions always pops up the negative sign. That's enough for this video.